we're moving on to the next component, which is the barrel. And so it's made of PVC. It's got some measurements here. It is 320 millimeters long, PVC barrel. We've got some more detailed plans down here, which shows some more information. Now the barrel itself, so we're going to cut that to length on the bandsaw, on the power hacksaw bandsaw, metal cutting bandsaw. Don't use cutting fluid, same as brass, just use it without coolant, without lubricant, doesn't need it. And as you can see from the end here, we've got some finishing work to do. Now the ideal way to do that is to take it to the lathe, put it in the chuck of the lathe, and then machine the end. One of the problems we find straight away is that the PVC tube actually won't fit through the spindle of the lathe. It's too large in diameter, and we want to machine out here. Now if I tighten that up and just do it up, just remember you're clamping on plastic, so you don't want to go too tight, otherwise you'll just simply distort the shape completely. And we don't want to do that. We just want to grip it, and we're going to machine the end. Now the problem is, you can see, is that as soon as we approach this with the tool to face this off, then it's going to try and climb up over the tool. And so we need some means of supporting that. Now the means is, we need to steady that on the end somehow, and we're going to do that by taking this device here, which has got 3 touch points, and that is called a fixed steady. And we're going to take this from this part of the lathe, it's just simply sitting here at the moment, and we're going to bolt it down onto the bedways. Now before we do that, we need to give these bedways a good clean, as we do with anything on the engineer's lathe. When we bolt anything up, clamp anything down, including the tools and tool post, we make sure we remove any swarf so that everything is sitting on a true surface. I mean, a lathe is only as accurate as the bedway, which is here, and if this is a good condition, then it's only as accurate as how clean it is. Now I'm going to use the drill chuck and put it in here just to get it centered initially anyway, so that I can then have these contact points, the rubbing blocks, just touching. Alright, but before I do that, I need to remove any burrs in here, so I'm going to use the non-measuring part of the steel rule at the end, just the sharp edge. I'm going to rotate this slightly and just scrape the inside. I'm not changing its shape, I'm just simply removing the burrs which are on the inside, so that when I bring the tailstock up, that and the chuck jaws, this 3-jaw chuck jaw simply sits in the middle. I'm going to lock that, put a little bit of pressure on it. Now that's going to maintain that that is pretty much central already. I don't want to turn the lathe on because it will simply melt the plastic around here. But what I do want to do is bring these rubbing blocks down until they just start touching. And the method I'm going to use, because it's hard to tell how much pressure, I need to clamp that down first onto the bedway, which has been swept clean. Just firm, it doesn't need to be real minty tight. I'm going to use a strip of normal photocopy paper. If I take that photocopy paper in there, and then if I wind down the rubbing block until it just starts to grip the paper, so like that, so I can still move the paper. I'm happy with that. If I bring this rubbing block in here until it does the same, just a little bit of pressure, just gripping that paper. If it tears the paper, then you're way too tight. I'll bring in the one around the back. Going to go back and check this top one again. Okay. Now I'm just going to rotate each one a little bit more. Pretty much half a division of these little the knurls on the handle at the top here. Now bump that. Okay, reset that one until it just grips the paper, and then half a division of one of these little bits here. When you're gripping on the paper, the whole point of that is that then you know how tight this needs to be. You can just kind of feel it, and then a little bit more, and we're onto it. Alright, what we're going to do now is turn the lathe on, take this away, bring the tool across. Turn the lathe on. We don't want to run the lathe too fast because plastic, well, PVC plastic can be cut at quite a high speed. It does tend to melt, and because this is being held in this fixed steady, we just don't want to force things too much. So we'll run it at a reasonably slow speed, maybe 300 RPM, around about that would be fine. Right. The next thing we need to do is put some grease on here, so when this starts spinning, instead of it creating heat and melting the PVC, it's going to lubricate it. Right, a little bit of grease, just a dab of grease there. Only one on one place will be fine, because as it rotates it'll spread it out, as you see. So now we're going to take this tool and we're going to face off like this. Nice and slowly across, feed nice and slowly. And then we'll move the tool onto the inside and move the burr on the inside like that. Do the same on the outside. Like that. And we are done. Now you do get a little bit of chattering sometimes because the PVC tube is not perfectly round. It's not like a piece of precision steel. The next part we're going to focus on is the end cap. Now the end cap is made of PVC. The particular size that I've ordered this time is going to be large enough to match the barrel size here. You'll see on this one here that the end cap actually looks like it's smaller in diameter than the PVC, but in fact the piece of material I've got is, at the moment, it's larger, so we're going to have to reduce it in size. So this is a piece of material, this is the end of the barrel. Remember, we have now faced that, and we've beveled that on the lathe using the fixed steady, and so we're going to machine that so it actually fits inside that and look like the picture down the bottom. So we have some measurements that we need to adhere to. This is quite badly cut, you'll see when I roll it. So when I cut it, I had to make an allowance for that. So the total length is 20, 34, 36, and so I have cut this to more like 38 because I'm going to need that to clean off the saw marks. Alright, so the first thing to do is put it in the lathe, face both ends, and then I need to make some decisions about how I'm going to mark it out, and then the procedure for doing that. So facing both ends, actually drilling a hole in the middle is going to be a very good idea because that will help support it in the lathe, and so we'll do that. You can see here we're going to drill a 4mm hole in the middle. We will need to use a combination center drill before we can use the 4mm drill to locate the center of the hole. Right, so we're off to the lathe, face this off. We only want to face enough to clean it off. So we'll face it and then we're ready for marking out. Right, so our piece of metal goes in, a piece of PVC, beg your pardon, goes in the lathe. I'm going to machine off the side, which is obviously the wonkiest. It's come off the saw, I don't know how that happened. Previous to when I... Alright, so I'm going to push that in there, pretty much as far as it'll go, so it touches the face of the chuck. Clamp it up. Remember, it is PVC, so you can't just winch it up real tight, just nice and firm. Think in terms of plastic, think in terms of these jaws can actually make indentations into the PVC. Alright, next thing is to check tool center height. So I'm going to use a method where I take a piece of steel and I bring it up against the outside of the PVC. Now if that piece of steel is straight up and down, that looks pretty good to me, then that tells us that the tool is on center height. Actually, it looks on the camera, it looks as though it's sloping out to the top, doesn't it? Alright, so I need to raise the tool slightly. Or do I need to change my camera angle? Yeah, it is actually straight up and down. Maybe it needs to come up slightly. Right, let's do that adjustment. So the question is, how do we raise the tool? Well, relatively simple. Slacken off the little clamp bolt that holds the tool steel, and slide the tool steel out towards your work. Because it's on a ramp or on a slope, as you pull it out, it raises the height of the tool. And bring that up till it just clamps it or holds it there in place. Let's check that again. See what the camera view is. That is definitely straight up and down. The camera view is distorting it a bit because of the angle I'm coming at. I'm going to leave it there at that now. Right, out comes the piece of steel, and we're going to face that off. Just keep in mind they're only going to face, wow, look at that, that's pretty wobbly, isn't it? Now I'm going to crank the speed up a bit more. What have we got in our chart? Our fastest machining material we've got on our chart, which is metal, is aluminium, and it says that this is diameter 50 approximately. So it says the diameter 50 can run at 420 RPM. So let's go, actually 460 will be fine. So that's 460 on there, wiggling the chuck as I move the gear lever, putting this lever on the red one. Alright. Probably take off a deeper cut than that. I'll need to do more than one cut. You can tell because the tool is not cutting all the time. I think I'll do it in 2 goes. Now it's a nice continuous stream of cut material coming off, so that tells me that this probably will be the finishing cut. Go nice and slowly, keep the tool moving, don't let the tool rub. In other words, don't stop feeding the tool across, because if you do, then it will rub, and if it rubs, then it creates heat, and the heat then causes the plastic to melt. It is tempting to pull away that swath that's getting built up there, but I wouldn't worry about it. Just let it stay there. It'll flick off if it wants to. Just like that. Alright, and so we end up with, is that done? Oh, there's a little, oh yes it is, it's alright. Looks like a little bit of saw cut there, but that is done and dusted. Alright, let's take that out, turn it around, do the same on the other side. The total length is 36 millimeters, and so we faced off one end, and so I really want to make sure that the total length of it now is the finished size, and so ideally we'd put it in the lathe and use the odd lead calipers to mark off the 36, but of course there's not enough left over to actually hold it in the chuck to spin it, you know, because you'd be holding it like about 2 millimeters and then trying to do this, and that's not going to work, is it? Alright, so we're going to get our big bold blue marker pen, and we're going to put some ink around here on the side where we want to put the scratch mark. Now when we marked out the barrel clamp, we actually used some engineer's ink, which is horrible, messy stuff. Not because of the ink, but because of the container. It's just a squirter bottle. So this marker pen is a much better way of applying it. Alright, we're going to set our odd leg calipers now on to that measurement of 36. You can't take them off the drawing because the drawing is not to scale, or not exactly anyway. It's not far away, but it's not exactly. Alright, so odd leg over the end, like that, and we set it on 36 millimeters, like that. And we'll just take that, it's still a bit wet. And we're going to, I don't want to wreck the plans, just carefully roll it We don't need to mark it all the way around. We just need one part like that. So that is 36 millimeters. And now we're going to go to the lathe and face down to that line. I can put some more on actually. Just got to keep in mind that you don't want to change the angle of this because it actually shortens the distance. You have to keep this in line with the length of the piece of material. Alright. We have just faced off the second side. You can see the blue ink which is left over. A nice smooth surface. What we're going to do now is we're going to drill through there, right through with this 4mm drill. You need to be real careful with that, because if you drill at 4.5 or 5, then it's simply not going to be small enough to carry the pipe fitting thread. Now, before we drill, we need to use a combination center drill, a little stumpy drill. Pretty much does the same job as a center punch when we're marking it on flat pieces of steel. And it guarantees that center is center. A drill like that one I just showed you, the 4mm drill, which is longer, because it is longer, it can wobble around a little bit. So I'm just going to bring that up, clamp the tailstock, start the lathe. Now this time I'm not only thinking of drilling the hole, but I'm also thinking of supporting this in the tailstock live center. So that's why I have gone in and gone up to the second ramp on the combination drill, so that when I put this live center in, that this slope on here fits and matches the slope in there. That's so that when we do that precision sizing of the outside, which, as you'll see from the plans, is an interference fit. So if we look at this, we're looking at this here. That diameter there, it tells us that for every 10mm of the barrel diameter, the inside diameter of the barrel, we're going to make this 0.1mm larger. And you might think, well, that's pretty silly. How can this be larger? How can this fit in a hole which is smaller than it is? Well, it can. It stretches. One part stretches. The barrel will stretch to match. And so that is called an interference fit. It's an engineering term for something which is going to stay together pretty much permanently, although it could be pressed apart. And that's what we want. We want an interference fit, a tight fit, which is also going to be airtight. Right, now we're going to drill through with our other drill. Move the tailstock back. Take out the combination drill. If I slide that back further, you'll be able to see that that sits really nicely inside there. That means we can put a little bit of pressure on, and that's going to hold this stable. Stop it from flicking out of the chuck, and make sure it stays central. And against the other drill, 4mm. Got that, 4mm, 4mm. Get it wrong, and it's like, got to start again. We'll just sit that in there, lock up the tailstock, lay it on. Now it's possible that the drill can block, so take it in and out a couple of times. Lock that again. And we are through. There, that's done. So we can put those drills back on the rack, move the tailstock away. We can eject the chuck in the usual way. We can then swap it for the live center, like that. Bring the live center up. And this time we're going to move our work out. Lock that tailstock up there. Now we want we want it held by at least two of the serrations in the jaw. So when you're looking this way, I can see that it's clamped by two. Just nip it up firm, but not too tight, you know, because it will leave those marks, as I mentioned already. Now we're going to bring this up and put a little bit of pressure on, just a little bit. We're not going to lock the spindle. We're just going to keep checking the tailstock handwheel just to make sure it's still applying pressure. And so we're going to machine along 20 millimeters from here to here. And that diameter is that critical measurement that I've mentioned already. So we need some ink, and we need to set our odd lead calipers on 20 millimeters. Let's get the odd lead set up. 20 millimeters. This time we can turn the lathe on while we're doing it. I'm going to get the tool out of the road so I don't got a bit of room to work. And remember, we're dragging underneath, and you can see where the ink needs to be, kind of about there. Like that. Let it dry for a little bit until we can leave a mark. See, I can't even scratch it at the moment because it's just too wet. It's still too wet. Waiting, waiting, waiting. Clamp that a little bit tighter, bring the tailstock up a little bit tighter, turn it on, 20 millimeter mark. Alright, we have our 20 millimeter mark. Now we're going to machine up to that line. Now what diameter are we going down to? Good question. We'll go down to we've got quite a ways to go. So the inside diameter here, I mean, if we go down to 40 millimeters or 41 or 42 millimeters, we're going to be fairly close. And at that point, we're going to change measuring instruments, and we're going to use vernier calipers so we can measure this, do our calculations, and then machine down. But in the meantime, we can pretty happily just go down to 40 millimeters using outside calipers. So if I set my outside calipers on, what did I say? I said 40 or 41. This is the approximate size. You know, we're just getting close. If I set that on 41 millimeters, and I know that the size we want is smaller than that, that gives us a chance then to use more precision measuring equipment to get us down to that size. Alright, so that's the size I can go down to now quite quickly, and as you can see, it's quite a bit of material to come off. So let's start that. Now if you turn it on and you notice that this is not revolving, then we're not applying enough pressure on this. That actually may mean I need to tighten that chuck a little bit more. In fact, I think at this point we're going to machine this down as well, so let's leave some marks. I'm going to have to tighten up the tailstock. Alright. Now I've just machined that down to a size which is quite close to the size I want, and at the same time I'm ensuring now that I have not moved this. So the tool at the moment, if I move the carriage along, the tool will be as it was when it cut that surface. And so this reading on here becomes quite important. A little bit closer. This reading on here becomes quite important. We're looking at the metric scale on the outside. And so we're going to do some calculations now to work out what diameter we want to go down to. Because you'll remember from the plans that the plans say that the end cap is to be machined to an interference of 0.1 millimeter for every 10 millimeters of the PVC barrel diameter. So the first step here now is to measure the barrel diameter. Right, so 0.1 of a millimeter for every 10 millimeters of inside diameter, and that is 40 millimeters approximately across the inside. So that is 4 times 0.1. So 4 times 0.1 is 0.4. So if I note that down on here, 0.4 millimeters. Now I need to add that onto the inside measurement when I measure this accurately, and that is the diameter that we will machine the end cap down to. Now we're looking at this booklet here, which you all have. There is a page near the second half of the booklet, and it's got some information to write in. So it's saying in here, the first thing we need to do is write in so it's calculating diameter A. Now diameter A is this diameter across here, which is what we're going to machine the end cap, PVC end cap down to. So diameter B we're going to fill in there, and so we need to measure diameter B right now. So let's do that. So if I take our piece of PVC, we're going to use vernier calipers, this device here, and we're going to take a measurement. Now of course we need to know how to read these, so I'm going to put that on the inside there. Now I'm going to open that. If I zoom out a little bit, I might get a better view. Put the vernier calipers on the inside. I'm just going to rotate the pipe gently until we get the largest measurement, because the PVC pipe is not always completely round, so rotate it until you get the largest size, and then we're going to lock the moving jaw on the vernier calipers, and then we're going to take that out carefully, and then we're going to do some reading of this. So, and this is going to be that number we're going to write in there in diameter B, which is the inside diameter there. Alright, now to read this, let's have a look. I'll zoom in a bit closer. Now if I've got this on macro, we should be able to, that one there, a little bit over top of our measurement. Alright, so you understand what we're looking at here. I'll zoom out again. So this is our vernier caliper. The reading the numbers we're looking for are in this area here. So let's zoom in. This is reading vernier caliper is 101. So at the moment it reads 30, that's 35, 36, 37, 38. It's almost 39. So you could guesstimate that it is 38 point maybe 7 or 8 or 9. You know, it's almost 39. So it's 38 point something. So we would write down 38 as a starting point. And then we would look along, to zoom out a little bit. Then we're going to look along this scale here, and whichever one of these lines lines up best with any one of those lines, then that tells us to an accuracy of 0.02 of a millimeter what the measurement is. So if we run our eye along it now, I'm looking through the camera, so we are 39 point, and as I said before, it's, you know, we need to be looking around the 0.8, 0.9 area. Let's have a look at that. And that's looking like, to me, so that's the 38.8 0.82, 0.84, 0.86, 0.88, 0.9. So I'm going to actually have to lift this up and read it. When you're reading, if you hold it on a very shallow angle like that, you have a better chance of reading. I'm just going to shift it away from the camera a little bit so I can read it clearly. Hold it up to the light. And looking at that, I have a reading of 38.86. So I'm going to write that down. 38.86. And so on the scale, we are looking at, I'll zoom in a bit more, try to get the camera straight on. Quite important you look straight onto the numbers. Where are we? Here we go. So I'm looking at 38.8 and then one division, which is 0.02, so that's 0.82. 38.828486 is the one that lines up best, which is that one there. 38. So it's 38, right along to this end here. This says 38, almost 39. It's 30, 35, 36, 37, 38, almost 39, which then takes me along to the scale here. Almost 9, but it's not. It's 38.86, that one there. Nice. Alright, so that gives me some numbers to work with. And so I've got on my board, I've got 38.86. That is the inside diameter of the barrel inside there. We've written that number in there, and then we do this little calculation thing here, which is pretty much what I'm doing up here. So we are saying that the diameter we want to machine to, which is this diameter here, is the inside diameter on the board plus 0.1 millimeter for every 10 millimeters of diameter. So if we add those up, keeping them in line. So if we want to kind of fill up this with more zeros, then that makes it clearer, doesn't it? This is still the same number. I haven't altered that. I've just simply put a 0 there and a 0 there. 6 and 0 is 6. 8 and 4 is 12. Put down the 2 and carry the 1. 8 and 0 is 8. Plus 1 is 9. And then we have 3. So the measurement we want, the interference measurement we want is 39.26. Now when you do it, your PVC may be slightly different in diameter, so as long as your calculations are true to what you're doing, we should be fine. Alright, we're going to go back to the lathe now, and we're going to machine that. Now we're back to the lathe. Now the starting point is to get a reference measurement of here. Remember the compound slide adjustment, I haven't changed it, so it's sitting in the same place. So if I get an accurate measurement of here, lock that sliding jaw, take the way and read that, then that gives us a starting point.